In this video, we're going to be looking at acceleration for the mechanics section in NCEA Level 1. During this video, I'm also going to be referring to this set of flashcards here, and you can get yourself a free copy from my website at sciencescribe.co.nz. Now, acceleration simply refers to when we change something's velocity. Could be getting faster, could be getting slower over a certain amount of time. The triangle in that formula is simply read aloud as change in. So when I see triangle V, if the V stands for velocity, I read the triangle in front as change in, so I can read triangle V as change in velocity. Same story for triangle T, I can read that as change in time. Now, thing about this formula and its working is that when it comes to acceleration and velocity, don't get the units mixed up. For velocity, it's ms to the -1, and for acceleration, it's ms to the -2. Time and time again, I see people mix those up. You don't want to be one of those people. Now let's say I've got a car and it has an initial speed of 70 meters per second and it takes 5.4 seconds to increase its speed up to 120 meters per second. If I wanted to calculate its acceleration, I would just take triangle V over triangle T, which is the change in velocity. I need to work that out. So I take 120 minus 70, which gives me 50 meters per second. Now if you're curious, do I take 120 minus 70 or 70 minus 120? Just remind yourself, take the final speed and then take away its initial speed. Final minus initial. It finished at 120, so I'm going to put 120 down first, and then I'm going to subtract 70 because that's what it started with. Final minus initial, finish minus start. Now the change in time is just going to be 5.4 seconds. Throw that into the formula, and that gives you an acceleration of 9.3 ms to the -2. I can read that as either 9.3 ms to the -2, or I could say that the car's speed is increasing by 9.3 meters per second each second. Now let's say we had a velocity time graph. This gradient, the slope or the steepness of that graph, can give you some information about an object's acceleration. Now if I wanted to calculate the steepness or gradient, in math you would have come across this formula rise over run. If I was to look at the rise component, I'll be referring to the vertical axis, which is velocity. The run component, I'll be referring to the horizontal, which is time. So when I take rise over run, I'm actually taking rise velocity over run time, velocity over time. The gradient, the slope, then gives me information about its acceleration, because if it's really steep, I could say it's got a high acceleration. If it's not as steep, I could say it's got a low acceleration.